So back to the first type again, the platy type of soil structural unit. Platy types of soil structural units could be found either at the soil surface or below at some depth in the soil profile. A platy type of structural unit is one where we have actually a series of platelets that overlap each other in that particular soil. Now, if this were to occur at the surface of a soil, it would normally cause a crusting or a hard coating or surface to appear on the surface of the soil profile. Now, I think you can see that that would be non-desirable, because if we had plants trying to germinate and emerge or come up through this, that can impede their progress. But it also, platy types of structure at the surface of a soil act as a barrier to air exchange or oxygen exchange in the soil profile, and also would serve as a deterrent to the intake of water by that particular soil. If a platy type of unit were to occur at some depth in the profile, not at the surface but down in the profile itself, this would also be non-desirable. And it would be non-desirable because these platelets have a tendency to act like cementation layers, further restricting water movement that has made it into the soil but is not allowed to percolate down in the profile with time. And these platy types of structural units can also serve as a barrier to the growth of roots down below that particular level in the soil. These oftentimes are referred to as cementation layers or hard pans when they occur at some depth below the soil surface. The second type of soil structural unit that I'll describe for you are those that are prismatic. Actually, the broader category here is called prism-like, and it is broken into two subcategories, the first of which is prismatic and the second of which is columnar. Well, prismatic and columnar are very similar to each other. These types of structural units are longer vertical columns which exist in the soil, meaning that the natural breaks or fissure points between the structural units occur in a vertical fashion at some depth in the profile. Prism-like, whether they are prismatic or columnar, do not occur near the surface of the soil. It takes a certain amount of pressure, overburden, and time for these types of structural units to form. So we're going to expect to find the prism or prismatic and columnar types of structural units down in the soil profile, typically definitely below the zone of cultivation if it's a cultivated soil, but even in a non-cultivated soil, we're going to expect to see those down not near the surface, but at least starting a few inches or more below. Just the growth of roots of plants into the surface part of the soil are really not conducive to the formation of these larger prismatic or columnar types of units. Now, there is a fine difference between prismatic and columnar. If that soil aggregates and or separates between structural units and the edges of those aggregates are very sharp and angular, then that is referred to as the prismatic type of structural unit. If, however, the edges of those structural units are much more rounded and don't come out to sharper edges, then that is referred to as a columnar type of structural unit. Once again, these are going to occur at some depth below the soil surface. Typically, we see these in cultivated silt loam soils in the subsoil region, or definitely below the zone of cultivation. Another type of soil structural unit is the block-like type of structural unit. Blocky or block-like types of structural units are smaller than are the prism-like ones. They can occur not at the soil surface, but near the soil surface. They don't require quite as much time and pressure overburden of the soil above for these types of structural units to form. The block-like ones are put into subcategories of angular or subangular blocky. That again has to do with the edges of these structural units or PEDs and whether they're sharp and angular, which would be the angular blocky, or whether they're more rounded and have a less angled edge to them, which of course would be the subangular blocky. Sizes of blocky structural units are much smaller than they would be typically for the prism-like ones. They are much shorter in vertical dimension and much more uniform in terms of the vertical dimension versus the horizontal dimension within the soil profile. Blocky types of structural units are probably more prevalent in soils with a little bit higher clay content, in contrast to the columnar and prismatic being more typical in subsoils where we have a higher percentage of silt and a lesser percentage of clay. That's not always going to hold true, but I'm just trying to give you some generalities at this point in time. The final type of broad category for soil structural units is classified as being spheroidal. Spheroidal are relatively small structural units. They're put into the two subcategories of granular and crumb. Granular are very small particles. It's where we have a small number of particles adhering together. And crumb would be more typical of a slightly larger type of unit. These are most typically found in the surface soil, especially in the surface soil where we have an appreciable organic matter content and or where we have cultivation occurring. In a cultivated or recently cultivated soil, we would like to see our structure end up being in the crumb type, even if we didn't have some larger size crumbs versus even larger size units beyond that. But what we want to avoid is the breaking down of the surface soil structure into a very non-structured state, either being single-grained or massive, meaning a lack of soil structure, because this is going to cause more interference with aeration and more interference with water intake and holding in those particular soils. So those are the four basic categories then of soil structural units: the platy, the prism-like, the block-like, and the spheroidal. And of course the prism-like has two subtypes, prismatic and columnar. Block-like is either angular or subangular, and the spheroidal is either granular, which is more typical of coarser, higher in sand content soils, or the crumb, which is more typical of the loamy and or silt loam type soils, especially after recent cultivation. Now, what do we do from a standpoint of soil structure? When I say we, I'm talking about what do we as people who utilize that land, how do we affect soil structure? Well, we have a very great effect upon the structure of a soil, especially in cultivated types of agricultural purposes. What we're trying to do is we're trying to avoid compaction of the soil, because compaction of the soil is actually where we've lost the soil structure. It allows a much more massive type of state to occur, and when this occurs, it is not only a barrier to water intake and movement in the soil profile and adequate aeration to the root zone, but also, of course, is going to reduce the intake rate and the growth potential of roots for that particular crop, whatever it might be. So what we're trying to do is we're trying to work the soil at the right moisture content, because if the soil is too wet, it has a tendency to form very large clods or aggregates when it dries, especially if there's any amount of clay in that soil. If it's too dry, when we go through and cultivate or work that soil, we break down these structural units. We have a tendency to powder or pulverize the soil, thereby also causing similar unwanted poor physical relationships in the soil. One other thing we can do if we have soils that have hard pans or cementation layers that occur beneath the soil surface, if we go in occasionally with deep tillage or ripper type instruments, we break these hard pans up. That is an actual direct way in which we can improve the structural relationships in the soil, is by breaking up or penetrating these deep hard pans with deep tillage implements.